Okay, today we're going to be talking about how you can build the Robby the Robot gyro dome ride assembly. This is a decorative base for display purposes. You can do whatever you want with the mechanics we're going to be building. So, this was the prototype one, and then this was the final files one. The hardest part of this whole project is actually building the gyro discs themselves. And so let's just start. Let's start with a picture of the actual Robby the Robot dome. And maybe I could even zoom in here. This is a picture of the screen used Robby the Robot dome assembly. And it's interesting for a number of reasons. One, it shows the main disc that the wire hoops connect to. This is the main one here, and here it is here. And basically it's a round disc of clear plexiglass with grooves machined into it and holes that the wire hoops pass through. And then in the plastic disc where they machined the grooves, you paint that white. And it's time consuming. It's not that hard, but most of you aren't going to be able to afford probably to hire a machinist to turn those discs for you. So I had to come up with another way that you probably could do it. And I'm going to bring some examples over in front of the camera that we will be talking about here shortly. Okay. So first, just changing the dimensions of that disc into something that's 3D printable. This could be 3D printed, and was, in what's called, on my FDM printer, and using what they call clear, which always comes out frosted, not clear. Now if you have a resin 3D printer, you probably could print this and actually have this come out as a clear usable part. And if you did that, then all you're going to do is go back and paint the grooves in it white, like so. It's hard in front of the camera. White, and then be ready to do the wire hoop part. But if you don't own a resin 3D printer, then what you can do is buy some silicone rubber putty at your local craft store, and then some clear resin. And this one is just cast in clear resin. The foggy areas are the areas that are going to get painted white. White. Like that. And the rest of it's just clear resin. Now it's not as clear as if you actually had one turned in acrylic, but it's clear enough it's going to give the effect. And so those would be two options. One, have a machinist turn you that disc, to 3D print it and just live with the fact that it's not clear, or 3, make a rubber mold and cast clear resin parts to use for that. And then there's one more option. This one is made entirely out of 3D printed white plastic. There's this main piece here has parts that join it together, prints as one piece down, and then these hoops print individually and you just glue them into place. This is actually the easiest way to go. It doesn't look half bad either. I mean, it doesn't look screen accurate, but it looks quite good, and it's very lightweight because there's no metal involved in this. What else? I think that's about that. I think I've got some pictures. Let's close this and find a picture of the metal hoops. So basically you're going to make a whole bunch of metal hoops that match the white areas that you've painted. Obviously you got to paint those first. Just lay the wire in there until you get them hooped. I've found different things to bend the wire around. Spray can bottles, rolls of tape, anything that's round and in different sizes, you'll just bend the wire around till you get the right shape and then cut the ends. Now, as far as the wire goes, you could use just copper household electrical wire, like 12 gauge copper wire. I ended up using this aluminum wire, which I'll show you a website where I bought it. You can probably get it at craft stores too, because it's used for a lot of different things and they sell it in different gauges. Because it's easy to bend and it's very lightweight. And the easy to bend part becomes important when you do that first little one in the middle. You have to put it in first and then you work your way out. And by the time you get to this one, they're easier to put on because you can work the slit in from the outside, rotate the ring around, then rotate it around and super glue it in place. The one in the middle, you bend it in that little teeny hoop, which basically I bent the wire around a pencil. You have to twist it till it looks like a figure eight almost, and then work it into the hole and then twist it back again. The first one's the worst. Then they get easier and easier and easier. And the very last ring, the outside ring, which will go for a hole, it's where I'm holding here and clear over to that hole there. When you put it in, it actually passes through, is this on screen? Passes through this part that holds the ring. You pass that through there and you'll do the glue joint up top. And that way this whole assembly is held onto there by the metal ring. I think I've got more pictures here. Let's take a look. So here it is with Mormon, and you can see what a crappy job I did of painting that. But hey, what do you want? I'm old. There I am with a little brush trying to paint those. And in hindsight, I think probably an easier way to do that is use your acrylic latex paints, put it in there, and then just come back with a damp washcloth and maybe a piece of cardboard so it can't curve in, so it's held flat, and just brush over the top to remove most of the paint off the top surface. And if there's a little bit of paint left in the end, then you just go back with some because you remember there's indents into this. The painted part's down inside. Come back over it with some 400 or 600 grit sandpaper, wipe that off and clear coat it, and that would probably give you a perfect finish. Here's a set of the rings, so you can see from the littlest working their way up before they get put in. So you can see how you'd have to take and do a bend there. You'd grab the open part and twist them opposite ways so that you could fishtail one end in, and once it's in, then you bend it back into a circle. These are getting to the next part of the build. Do we want to start talking about that? Yeah, why not? So these rings that we've just made are going to fit into the slots, into these holders, and these holes are where that one outside ring is going to pass all the way through, and it'll hold this clear gyro part in there. And then once it's in there, I also dump in, I use your regular CA glues, your super glues, in a fast set accelerator. So when I'm holding everything nice and square, I just zap it and it's all set up at that point. These gears are going to go inside the dome, and these are going to form the axles, which fit into the gears and fit into these. And these form the backside of the axles. By printing the axle this way, you make the strongest part you can on an FDM printer, because your print lines are like this. If you printed it vertically, it could tend to snap off. So you print it this way, flat. You don't have to use any supports. These little half-moon wedges are going to glue onto this fat part that's against the bed to form a complete circle. I'll show you more of that in just a second. But just to maybe make some of this more clear, these are some pictures way back. I don't know if I can get them all in there without hitting my computer. And who knows where things would go if I did that. But you can see inside this bell, this is one of the very early Robbys. It's not the very first one, it's probably like my second one, where I had the brass bell and have these little gears and the gyros coming in. And up here you see that. Basically what I did back then is I found egg beaters, the hand type where you turn the crank with your hand. That's the gear where the hand crank would move, and these little white gears are the ones that are on the egg beater portion. So you end up having to buy 2 egg beaters to get the 3 gears, because each egg beater only had 2. And maybe I can get closer this way. So there's a picture of the little gear on the end of the gyro. So you can see back then, I didn't know, or if I knew, I couldn't afford to do the solid disc method of making the gyro. These gyros are actually made completely out of styrene, whereas I made wood forms and heated square styrene stock and glued them all together. That's a ton of work, besides not being cracked, but it still looked pretty good. And basically the flat gear, we're looking at the top of Robby's head. You can see where the egg beater gear went on the top. This metal shaft is coming from my motor unit inside. This shaft here is the one that rotates. This shaft here stays stationary because that's the one that the gyro lamp's going to connect onto. So then I've stacked the part on there. Alright, I think that's all we need from that. I'm going to give you one more inside view into the build. And that's going to be this picture. This picture is an actual picture of the screen-used Robby the Robot gyro section taken apart. This was in one of the many refurbishments, rebuilds, if you will, of the robot. And there's the gear that's going to sit on top of the head, if you will. It goes together a little differently. Their bell is very thin. This actually would have been spun. And if you want to see how to spin and shape metal, you can find lots of YouTube videos that explain that. But they start with a flat blank, spin the metal back against a wood slug, and end up with a thin hollow shape the way they want it. So the little gears are mounted on the inside. They're going to run on this flat gear. And in this case, they had a bottom cap that screwed onto that with 3 screws. And over here, you can see some of the gyro units. The main plastic disc there, the wire parts there. They used brass or bronze bearing inserts. This unit up here is the motor assembly. This is like an old American Globe gear motor that went up and ran against another gear because they have to be able to drive through that hollow shaft. More of this will become clear in a moment. And I don't know what that is, or whatever it is, I want it to go away. There we go. Okay, so we're back to the screen pictures. What else have we got up here? Don't know. Let's make this all go away and see where we're at. Okay, so it doesn't matter what color plastic you're going to print in. In this case, I had some of this fire engine lime green left over from the fireman robot that I had just done. We're looking inside the bell. You can see the gear part that we just talked about. We showed all the parts, the shaft, going down to the nub. This is what it looks like from the inside of the bell. Here it is from the outside. Remember, our disc's going to go in, the wire's going to go through. That should all turn freely. Here's the same parts after I've painted them. I didn't do any sanding, obviously. You probably would want to prepare that, make it look more like metal. And this is just an example of some of the crap you found at my local hobby store when I showed you the ones that I did in resin. I took the disc that I had 3D printed and used this putty material, silicon putty material, to make this mold, and then poured this clear cast resin into that. I actually don't suggest you use the epoxy clear cast resin because right on the box it says it takes 72 hours minimum to harden up, and it's true, it does. And slow curing resins in silicon rubber molds is usually a bad idea because that gives it enough time to seep into even to the smallest pores of the silicon rubber mold, and it'll shorten the number of parts you can get out of the mold. In fact, you may only get one part out of it. And if you use a mold release, then your clear part isn't going to be clear anymore because the mold release leaves a film on it. So it's better if you can go in there with a polyester clear resin, because that stuff sets up, in 10-15 minutes, and it cures very quickly and hot, and it'll come right out. The only real problem with most of the polyesters is they do yellow over time. Okay, so we're going to start part of the mechanical build. This frame is going to be up inside. It's actually this frame here. And this motor here is what we're assembling. As you can see, there's 2 places for screws and 2 places for screws. So this motor actually would turn this way. The shaft would be poking inside and the screws would hold it in place. again, in America, when you're using one of these TT type gear motors, and this is the 48:1 ratio one, again, the 120:1 would probably be better because everything would turn slower and look better. But the 48:1 works. And screw it in place. And this shaft actually has a height division here and a larger end here. And that larger end is going to glue down inside there, all the way flush down. This tube stays stationary because we just glued it. But the dome light's going to be on top, and the wires from the dome light pass all the way through and can come out the bottom. Then the outside of the shaft forms an axle for everything else to ride on. So here it is with the motor screwed on like we just talked about. The shaft glued in place. And then there's a large drive gear that just slides down over the shaft. And there's a gear that goes onto the motor shaft, and it just slides onto the shaft. You don't need to secure either one, because what we're going to do now is put a bead of glue around this and glue it up inside this housing. And it can only go in the way because there's a cutout groove in the housing. I'll have some pictures of that here shortly showing how that goes. But once it's glued in place, it should look like that, and you should be able to put power on there and everything should run. I had the dual shaft motors. If you have a single shaft motor, you don't have to cut anything. If you have a dual one, you need to snip off the unused leg so it doesn't protrude out the bottom of your device. Going to look like that from the top. There's the support piece that I put some glue in and pop it all the way down in place. The gear is going to glue on top of that. Here's a bottom view. Now you could use any sort of battery assembly you want. This is one of those 3 AA battery boxes that actually has a switch built into it. But the problem with using the switch is you would have to put like Velcro or something on here, because see, the batteries go on the back and the switch is on the front side. So if you flipped it over and then every time you wanted to turn it on, you'd have to lift the thing up to get to the switch. So I just decided, screw that. I have this holder, left the switch in the on position, glue this piece right onto the top of here as long as you don't block the hole that the wires are going to come through. And then added a place for a slide switch like I standardly use, so I can control it there. That way the battery opening side is facing the bottom, so I can get to the batteries when I need to. Here's the gear part. It's going to glue right on top of that. Just when you get it on there, just move your fingers around to make sure everything is lined up nice and square. And that's just showing the top part seated down on it. Okay, we've moved on, and basically what we're showing you there is this radiator fin part, this aluminum looking part. I just call it the dome light support on the files, but so that it could be printed without any supports and so that it would look the best, each one of these parts is a separate piece that stacks together, and they can all be printed out just like that. And this is showing what the parts are going to look like from the very bottom. That's closest to the bell, all the way to the top, which is closest to where the dome light's going to be, the order that they stack in, because there are differences. I mean, these two are the same, but other than that, there's slight differences in them, so you have to get the right ones. And when you stack them together first, just to make sure everything is right, that's what it should look like. A longer area at the top, a shorter area at the bottom by the bell. The small holes should be down here at the bottom of the bell where it's going to fit on that shaft that we just glued on. A larger opening at the top where the light is going to go in. This is showing the wire hoops in the 3D printed other version. If you didn't do the resin cast, you can do, when I did this one here, that was all 3D printed. It's basically this form, but with the holes. Instead of printing and gluing these parts on, you can tuck wires through. So you can do a version like that. And that's what that would look like if you did. You can see the little glue marks. Then you come back and you have to, well, in this case everything's white. I don't have any clear to worry about. Just spray paint the whole thing white. I talked about that aluminum soft wire that I used, 12 gauge. That's what I used. But anyway, the website, I think I have the name for it here. I don't see it in that picture. But of course, if you just put in aluminum soft wire 12 gauge, you'd come up with, oh, that just happened to be whimsy.com. I don't know. I mean, I bought this metal probably 10 years ago, but obviously I had gone to the website or I wouldn't have this frame grab that I took. So they do sell it, which means other people would sell it, which means you can probably find it on eBay or Amazon and maybe even cheaper. This is showing that gyro one that I talked about with all of the separate little pieces that will get glued on. This is, like I say, this is the easiest way to do it. And if you don't have any wire, and if you don't have a machinist, and if you don't feel like casting, this would be the way to go. And there's that one that I already showed you, different angles. And here's one of the units assembled. The first one that has the clear disc with the wire. This one has the 3D printed center part with the wire. Here we are working on the dome light. This piece prints, you're going to use on your FDM printer clear PLA, and it'll be hollow inside. It has a hole in the end that's meant to align with a 10mm jumbo LED. I used a white one here. In this case I had a 39 ohm current limit resistor, but anything from a 39 ohm up to a 220 ohm would be fine, but you do need some sort of current limiting on that. And use some E6000, also sold under the name Goop. Just slop some around the bulb and slide it up till it's flush with the bottom of this. This is shaped this way to look the same as the original automotive bulb that was used. And I'll have a picture of the two of those here in a minute. But here you can see the LED is glued in. This has now been spray painted chrome. You put some glue around that, jam it down in there. There's going to be a cage piece that goes around this. Here I'm just kind of test fitting everything together, but you can see how it is going to drop down on the top of that shaft. Here's the cage that goes around the light. Prints in two parts. The original one on the screen used robot is in two parts, but it was all acrylic plastic. And this should be clear. So if you have a resin printer, print that on your resin printer in clear. I had to go with FDM. It so means it came out frosted looking instead of clear. A little unfortunate, but still better than nothing, right? So there it is on top. The bulb is supposed to look frosted. Like I say, the lamp part should be looking clear, ideally. So let's go back and see what files I have here. Here we go. I wanted to show you this one. This is the type of bulb that was used in the original Robby, size-wise. You don't need the two filament type. This is like break-in turn signal. Theirs would have been the single conductor, like just turn signal bulb. Or in the old days, they were single filament bulbs for break-in turn. They were just two bulbs. So the shape was the only thing that was important, because we weren't going to be fitting this big gas hog of a bulb inside there. Plus we don't need the heat buildup around all these 3D printed parts. Let's see, is there anything else that we need to show? Probably not. I think that about covers it. The files are going to be up on Thingiverse. I'll have a link in the description down below. And there are the other projects that we've done in the past. You know, if you want to build the heart box, either the 1950s style or the 1960s style, or if you want to make the Forbidden Planet blaster, I'll have links to all those projects down below if I can get far enough back to get everything in screen. But you can see that I think it turned out quite well. Don't have to use a display base. You can just use what's here to stick inside your full-size Robby if you want, I guess. But it's a nice gyro spinning action, and then you see it's turning the right direction counterclockwise, and the LED top light looks quite good. So it's actually a very simple build, the way everything goes together. The hardest part is actually making the gyro rings. That's it. I can't think of anything else.